What? You're just a baby. So this one was whining so much to be in the videos, we're going to put her in almost every time now, right? Is that all you wanted? Now she's super quiet. She's like, I didn't want to be on my back, but yes, I want to look cool and then be in the video. Okay, that's better. All right. Okay, we'll put you in the poster one of these times, but we're not doing that right now. We're doing math videos. Another hour. Okay. Now go. Be quiet. She will not be quiet. So, what we're going to do is, yeah, exactly. I knew it. It took like 3 seconds before you just yap. Get. So, what we're going to do is we're going to do more of the word problems, and we're going to start towards these more complicated, or the ones that you may not like at all once you have to take the calculus class. But we're going to get word problems involving related rates and optimization and these types of things. So here's the start of this journey. What we're going to do in this one is all we're going to do is start modeling functions, is usually the section that they're talking about in when we do a class like this. So once you have functions, what do we want them for? We can model all kinds of scenarios with this and then do all kinds of clever things with those functions once we model, and then use function theory. So what it says is we have a poster which is going to be described. Some poster is 7 inches longer than it is wide. I have no idea if that one actually is, but it seems reasonably close to our example. I'll check in a second. We'll fact check. Let me clarify. I'll make someone else check those dimensions. So a poster is 7 inches longer than it is wide, and it wants us to create a function modeling the area of that poster with respect to the length is what we're doing. So first of all, in these problems, what you want to do is draw yourself a picture or look at the poster that I just pointed at a couple times, but I'm going to call this the length, and I'm going to call this the width arbitrarily. Once we give it a label, length and width, we can create this arbitrarily. But once I've done it, now what it said is, and we'll do one more thing, the area. I want to model the area, it says, as a function of the length. So how am I going to create that? So what I want is an area of the length, and usually we write f of x when you first start seeing functions, but this is the whole point. What we're going to do is model one thing in terms of another thing, and then you can change the dimensions, and then the area changes also. So how are we going to do that? Classically, what we have to do is we have two unknowns, so we have to have at least 2 equations or something to describe or eliminate one of them, so we can create a single function of a single variable. I know you don't know how to do variable calculus though, so chill out. We're not going to do any calculus here either. All we're going to do is find the dimensions. But the first thing we want is, we're going to keep in mind that we want the area as a function of length. But it gave us in the first sentence a clever equals equation. It says that the length is 7 inches longer than its width. So whatever W is, the length is W plus 7 is what it's telling us. And then now what I can do is solve for W in this. W is length minus 7, therefore. Why did I do that? Because it wanted in the problem us to find the area with respect to the length. I now have W with respect to length, and I now know in general area is length times width. I get that from this picture and the formula for area, and so now I had 2 equations, and now I put this one into here, and I get length times what was width, length times 7. So what does that give me? Long story short, that gives me area dependent on length as a function as L squared minus 7L. This is the area dependent on length as a function. Now what we're going to do is have some more fun, and if it gives us the area as 30, then what we're going to do is set this area formula equal to 30 and then find the dimensions of the poster. What we now have is, we know that the area is L squared minus 7L, which is now equal to 30, it tells us. So how do we solve quadratics? Bring everything to one side and set it equal to 0, and either complete the square or play some clever games to find the roots of these things. So this is if and only if L squared minus 7L minus 30 equals 0. I also tried to pick some clever numbers which are not standard for playing this game. What multiplies to give me negative 30 and adds to give me negative 7? negative 10 and positive 3, that's correct. So if and only if, I cooked them up last night, L plus 3 and L minus 10 equals 0. Now what do I do with that? What does that tell me? That says the length is either equal to negative 3 or the length is equal to positive 10. We can get rid of the negative 3 because we can't have a length which is negative. But what that's going to say is the length is 10 units long. And what does that say about the width? What was our width? Our original equation was the length was the width plus 7. So the width is the length minus 7. So the width is 10 minus 7, which is 3. So 3 inches by 10 inches. It's some skinny poster. It's not our poster. Close enough though.